Publishing data out through web services. In 1973, GPS developed by the U.S. Department of Defense was used for defense purposes. In 1983, Korean Airlines Flight 007 was shot down over the USSR when it strayed into Soviet airspace. That same year, Ronald Reagan issued a directive to make GPS freely available for civilian use. In 1989, the first GPS satellite was launched, and by 1993, 24 GPS satellites were available for public use. That same year, the World Wide Web was declared free for anyone to use by CERN. Fast forward to 2013, GPS drives multi-billion-dollar industries and feeds the internet. We come to expect it in all of our devices. Big data is driving a lot of what's happening in the internet today. If you look at the size of terabytes of data that each organization like this manages, for example, Kaiser Permanente's digital health records, 30,000 terabytes. It's a huge amount of data that obviously needs to be managed in an efficient way to get to it. The technologies available today to web service enable complex data. Our mobile devices do amazing things. There's a dashboard in the Yelp application to search for the nearest restaurants. It knows where you are and points to you on the map, enabled by GPS. That then searches for nearby restaurants which are rated by others and shared on Yelp for the Yelp user to find and even make reservations. Automating machine-to-machine communication lets humans focus on the task at hand. Is this a dashboard, GIS, BIM, or a facility application? It is all and more, and the DMLSS 4.0 should function like this. There's zero need for training. Users can come to expect this level of interactivity. It searches through massive amounts of facility data from multiple sources in real time on your phone, knows where you are, and does not require you to understand how GPS or satellites work or what database to use. Guides you on what to do, and even listens to you when you talk if you use Siri on the iPhone. It shares photos that others have taken with you and lets you collaborate by making comments and writing reviews. If you ask for direction, it can launch another mapping application to show you live traffic. This is just one of hundreds of thousands of apps that have been developed in the last few years, and this particular one is free, enabled by data that's accessible through web services in an open format and easy to use and develop applications. If we look at facility data, we're obviously still at the beginning of that cycle of making this data accessible in real time in an easy format. DMLSS has a lot of very valuable data as you look at facilities for all the healthcare that's managed by DoD and within the DoD with other agencies. There's graphical data as well as tabular data. And SEPS is obviously connected to it. SEPS is a starting point for defining the requirements of a facility. Then you look at BIM and CAD applications and data that do amazing things, GIS applications, the DMLS application itself, and computer-aided facility management applications for graphical view of the facility data, and CMMS applications. And then dashboards that let you see all this data rolled up. The only problem is that all of these applications are disconnected and the data does not flow efficiently between them. So for example, industry best practices and information that drives the requirements into SEPS that then defines all healthcare facilities for DoD and VA is then used, and BIM and CAD applications are used by design teams to actually resolve the design. GIS is used once in a while to define location. DMLSS then needs to get this data for operations and maintenance to feed into CAFM and CMMS interfaces. And then roll-ups need to be done in dashboards to report up to the executive level. Outputs from these applications, these standalone applications, are files. Files can be exported in a common format that can be shared between one and the next, but it still relies on somebody to actually take that file and import it into the next application. So it's a file export a file, import it into the next application. This doesn't happen on Yelp like I showed earlier. You basically push a button and you get to the data crossing across multiple different sources. There are some automated processes that are happening with APIs and links to data between applications. This is just the beginning, but it's still very much kind of an import and an export one-to-one between applications. And then there really isn't a very good feedback loop as you complete design to feedback into lessons learned or to be able to draw off of existing facility data to even start the renovation of a new project. You pretty much have to start from zero to collect what's available or accessible to start the design. So there are choke points between these loose connections with a dotted red line. These are identified here as loose connections that rely on applications sharing files or even third-party consultants to pass that data from one stage of the life cycle of a project to the next. How can we change this? Well, step one is to look at it as two different distinct pieces. There's the application and presentation layer that lets you have interfaces into the data, and there's the information layer of the data that is currently embedded in applications, but it should be split off. If you split applications from the data, you get the information layer, and you use the White House's 21st century digital strategy, and you create a security layer. You secure the data at the data level, not the application embedded with the data. Then you have a services-oriented architecture, or web services, data on a server that serves information to multiple applications. Then the presentation layer, or the user interface, could be a single application or many applications getting to the data. There's obviously a direct connection between DML's application and the DML's data on the server, and the same thing with SEPs, same thing with BIM and the BIM servers and BIM applications, GIS and GIS applications. This is still needs to be a very strong connection, but it's not the only connection. So for example, GIS applications can also use data from BIM or from SEPs or from DMLs or from other public data such as weather information. So GIS does not have to rely just on a GIS server. There are other uses for the data in GIS as it's viewed from the GIS user interface to get to the data. Same thing with BIM. There's multiple ways to get data into BIM, and if you make it accessible through web services, there's a lot more you can do with it. So for example, getting a utility line from a GIS server would be valuable for a BIM application when one is trying to design a new building and connect to the utility system. The same thing with CAFM and CMMS applications. They can draw from other sources. This is very different from importing and exporting. What we're suggesting here is that data can start to flow just like on the iPhone application from Yelp that we showed earlier, making it easily accessible and not being burdened by the technical aspect of needing to import and export data. Opens up a lot of different uses. So the same thing with SEPs. When you start a SEPs project, right now there's no way to access existing information of existing facilities, but imagine if one could draw from existing facilities or from lessons learned. This is not currently being implemented, but there's a potential in the future to make this happen once the data is disconnected on a separate server from the application. The same thing with DMLs. There's a lot of things that DMLs can draw from, including public data. So public data on the internet might be product information, for example, or weather data that is accessible publicly, and then also obviously from the DMLs and BIM and GIS servers as well. Mobile applications are exploding, just like the Yelp application. There are going to be a lot of applications that can be developed once this data is made accessible in a controlled fashion. Obviously, security is still an issue. You have to control who gets access to the data, but once that security layer is you log in, you can actually do a lot with this. So we kind of walk through applications as different buckets. We have different categories of applications, GIS and BIM and CAFM and CMMS applications. But the reality is you really don't need to isolate it into those buckets. If you look at the iPhone app again, nobody asks, is this a BIM app or a GIS app? I see a map on here. I see a list of restaurants. Is this a database of facilities or is this a mapping application? It really doesn't matter. You're able to use data on the fly and create applications that draw from multiple sources. So you can cross-cut across different sources to create even new functionality that would have been absolutely impossible before, without manually going to each application and extracting data and then combining it in another way to create that query or report that you need to do. As more services are enabled, applications that cannot be categorized into one type or imagined today will be enabled. Data is not trapped in the application that originally created it. It's liberated for any application to use. And a lot of new uses come out of that. For example, if one wants to ask how many dollars of work orders are outstanding worldwide, what new projects should we budget for? You need to find location, you need to look at the work orders that might be coming out of the CAFM and CMS systems, and be able to compare them side by side in real time. Where's the nearest medical center that has MRI facilities? This location-based, obviously, and information from the facility itself. A lot of different what-if queries are shown here that will be made possible by making this data service-oriented in a web services format, accessible on servers to different applications. Mashups of data from different sources will answer complex questions driven by relevant information in real time. And this big data becomes the DNA of healthcare. As this data is worked over time, new data is added, it's made accessible to more users, and this becomes an asset for a healthcare organization as it's refined over time instead of getting lost in each project. Services-oriented architecture and web services will synchronize data in multiple applications to support many stakeholders, regardless of what application they use. The application and presentation layer becomes the place where you actually look to many different tools to interact and call up data that's in the servers, not only just 5 servers that's shown here, it could be many servers controlled with a security layer. And if you look at the different ways that all of these applications and servers can interact, it really is infinite. This just shows some combinations of data and ways to actually look at data from different applications. The evolution from the current state, where we are in 2013, where it's a file-based exchange of information, to where we'll go in 2015, will happen in stages. It's not going to happen in one shot, but there's a lot that can be done very quickly. For example, SEPS is already moving in 2013 towards web-enabled, services-oriented architecture, and DMLSS can ride on top of that. There's no reason to reinvent the wheel. The 2015 target date for SEPS and DMLS to be fully web service enabled will support each other. It's no longer 2 different buckets, but there's data that needs to cross over from the full life cycle of a project. And there's a lot of ROI that can be generated from this. Imagine all these manual file exchanges that happen right now. Export data from one tool, import it to the other, and hope that all the data is there, and hope that the user that's actually making this happen knows how to actually correctly format it for import or export, or rely on a third party or a consultant that might be focused on the project and not be focused on the enterprise and the ecosystem of the data that needs to flow for a DoD. There's a lot of potential value there. And imagine again the Yelp application on an iPhone. If all of these requests that were happening on that Yelp application were done manually as exchanges, export data about a map, connect it with an Excel file of restaurant locations, find it on the map, find where the nearest traffic is, what the traffic conditions are and how long it takes to get there, call up the restaurant to make a reservation, find out where your friends are. All that stuff is happening in real time in a simple application like Yelp. We can bring the healthcare industry into that world, and we should, because it's expected now. The end users are expecting this level of interactivity to generate a lot of value by web service enabling healthcare data.